Good morning, everyone. My name is Twomey, and I'm the Planning Policy Manager for Electricity North West. This morning I shall be talking about the connection process for electric vehicles and heat pumps. The presentation is going to take about 30 minutes, with opportunities to ask questions in the middle and a wrap-up at the end of the presentation session. I'm joined by a couple of colleagues from the connections business who are just going to introduce themselves now.
Yeah, my name's Tom Glasgow. I'm the manager for the domestic connections team at Salford.
Hello, my name's Joe Davis, design engineer for Business Connections, Electricity North West.
In terms of content, I will initially set the scene and explain why DNOs need a simple and efficient connection process for low-carbon technologies, such as electric vehicles and heat pumps. I will then explain in some detail the process that Electricity North West has adopted to facilitate the connection of EVs and heat pumps. This will be followed by a Q&A session, specifically to talk about domestic heat pump and EV connections. I'll then cover the process for the connection of public and high-capacity devices. I'll then move on to list the relevant Electricity North West standards and policies, as well as other useful national policy documents. We've been connecting these devices for some time now, and we have learned some lessons, so I thought it'd be worthwhile just to share those towards the end of the session. And then finally a Q&A wrap-up at the end of the webinar. Just a bit of background to set the scene and what this is all about. UK government law is now enshrined zero carbon by the year 2050. So this is going to have a big effect on everyday daily lives. Petrol and diesel vehicles will be banned by 2030. Electric vehicles are critical to achieving this. As the regional network operator, distribution network operator, Electricity North West has a key role in enabling this. There are various forecasts. I've just shown one there showing EV uptake. And we're talking in the Northwest millions by the year 2030. And heat pumps have got a similar range of scenarios. But the main point to put across is these technologies are going to become very widespread. So we do need an efficient and easy method to enable them to be connected. All DNOs have been working on a simple connection procedure for domestic low-carbon technologies such as heat pumps and EVs. A standard connection process has been developed, and this is the policy for the connection of heat pumps and EVs. For heat pumps, it replaces the old forms A, B and C, which some of you may remember. Under the process, the installer may assess the suitability of the electrical service to accommodate the EV or heat pump. Using rules set out in the IET wiring regulations, the installer determines the total domestic demand, maximum demand, including the device. If this is less than 60 amps, and the installer judges the service is rated at 60 amps or more, they may connect and notify Electricity North West, subject to other checks. If the load calculation determines a maximum demand greater than 60 amps, they must apply to connect using the standard application process. The process is common to heat pumps and EVs, although some of the checks vary between the two technologies. On the link there, I've included a link to the Energy Networks Association website, who have coordinated the new processes. It's worth following. There's a wealth of detail, a lot of background information, also some of the forms that you need to submit should you need to apply or notify. So I'll now go through the process in a little bit more detail. This is a typical service termination, domestic service termination, just showing you the key components. So we have the incoming service cable and cutouts or main fuse, which belong to Electricity North West, meter tails and meter, which are the property of the supplier, and then finally tails going to the customer's consumer unit. The key point of the process is to identify that all of these items are rated at least 60 amps. Just out of note on this particular one, it's the incoming service cable is a mineral insulated copper conductor cable, also known as pyro, which is slightly unusual. They're quite common in multi-occupancy buildings, blocks of flats and so on, but for a domestic situation, they're a little bit unusual. And in this case, we would advise the installer to check with ENWL the rating of that particular cable. And you will find a wide variety of different types of cutouts, especially in older properties, anything pre-1960. You will tend to find a very wide variety of different types of cutout. Generally from 1960 onwards, it became more standard with plastic type cutouts, like the one in the photo, and more standardizing on 100 amp rating. Just one point to note, the installer must not remove the cutout fuse to identify its rating. That can only be done by ENWL or the supplier. So a little bit more detail on some of the checks that need to be made. What's the rating of the cutout? As I said before, generally from the late 1960s, 1970s onwards, plastic cutouts came in with a rating of 100 amps or 80 amps, quite common, but older ones can be less than that. 40 amps, 30 amps are not that uncommon in older properties. Any safety concerns? Are there any obvious signs of damage or burning to the equipment? Any other issues identified? One thing which may be quite common is looped services. This is where a single service cable comes into a property and then continues on to the next door neighbour, and then sometimes the next door neighbour after that. So in effect you've got 2 or 3 properties fed from a single service cable. This was fine for gas heated houses with a relatively low demand, but as soon as we begin adding quite high loads, such as an electric vehicle, it's unsuitable, and our policy is to remove that loop. Does the calculated maximum demand of the house and the EV or heat pump exceed the cutout rating? There are methods in the IT wiring regulations for calculating the domestic maximum demand. That's what we would recommend as a standard approach, and then add on the demand of the electric vehicle or heat pump on top of that. If the maximum demand is more than 60 amps, again, it would result in a requirement for applying to connect. So if any of those questions, if the answer to any of those questions is yes, if you don't know the rating, if there are safety concerns, are there any other issues identified, is it looped, is the maximum demand more than 60 amps, you have to apply to connect, and the email address for the application is given there. For EVs, there's some further specific checks that need to be made. Does it have a DC output, i.e. does it have power electronic equipment? If it's AC output, is it more than 60 amps per phase? For a whole current metered supply, as we'd typically have in a domestic situation, or if it's a CT metered supply, so in a bigger installation, such as commercial premise, is the AC output more than 30% of the contracted maximum import capacity? So if the answer to any of those is yes, again, it's applied to connect. If it's no to all of them, it's connect and notify. And the email address is given there. There is a form for notifying on the ENA website. The link for that was on a previous slide. For individual applications, we do also allow notification on a spreadsheet, providing it contains the same information as a notification form. We do know that PodPoint and some of the bigger installers like to do it that way because it's just more efficient for them. For heat pumps, there are some specific checks that need to be made. So is the heat pump under the control of a single controller, or do we have a controller controlling multiple heat pumps, as we might find in a block of flats? Is the total heat pump AC input less than 32 amps? Is the heat pump listed on the online database? Now, again, on the ENA website, the Energy Networks Association website, they've created an online register of heat pumps by make and manufacturer, which provides a lot of technical detail, which is helpful to DNOs. It also has a classification of connect and notify. This means DNOs have already assessed these heat pumps and judged them small enough that we don't need to consider each one as an application. You can just connect and notify. So if the answer to all of those questions is yes, again, you can connect and notify ENWL using the email address given. If the answer to any is no, then it's apply to connect. So that's a brief summary of the connection process for domestic electric vehicles and heat pumps. Just in summary, it is based on the installer doing an initial assessment, following the checks which I've talked about, and the decision will be either to connect the device and notify us, or to apply to connect. So, are there any questions at this stage? Yeah. Okay, take silence as no questions, so we'll progress on to look at higher capacity devices. So we treat the higher capacity devices, and I'm talking here about devices generally 75 amps or more, public EV charge points. We treat them slightly differently because we do know that from a power quality point of view, they do emit more in terms of harmonic current, so they're more likely to potentially cause disruption to our network. We do have obligations under our distribution code to manage power quality on the network, so when we get new devices connecting which are potentially disturbing loads, we do have to follow a standard process. The power quality assessment that we follow is a document called Engineering Recommendation G5. It's standard for all the DNOs in the country, and it basically ensures that connecting new devices to the network won't result in power quality issues for that customer or any other customers nearby on the network. It involves basically a two-stage process, and we do need emissions data for the device that's being connected, specifically harmonic current emissions from the 2nd to the 50th harmonic. This will allow the stage 1 assessment to carry on, which gives a pass-fail outcome. It's either within limits or it's out of limits. Failures may progress to stage 2, which is a more detailed assessment and involves gathering of site measurements of background levels of harmonics at the point of connection. ENWL can do this service, or alternatively the customer may do it themselves. Alternatively, if we do get a failure at stage 1, the customer could request an alternative point of connection. So that might be of interest to developers who are just installing a number of charge points in an area, and they don't have to be specific to a location. They could have more flexibility. And finally, for multiple installations, diversities are described in our document on the connection of low carbon technologies. So if you're having multiple charges in one point, we do have rules for the diversity and assumed diversities between them. So just moving on to Electricity Northwest policy for connections. The new policy that we published this year is called ES230, Connection of Low Carbon Technologies, and there's a link there which will take you to the library on our website. This covers all low carbon technologies, so domestic, heat pumps, electric vehicles, public electric charge points, charge points in multi-occupancy buildings, all different situations. So that is a key document. Behind that, we do have other Electricity Northwest policy documents. So EPD 283 is just covers LV network design in general. So that would, connections would have to comply with that as well. And then there are more national documents. So I mentioned Engineering Recommendation G5. That's also available to download from the Distribution Code website. ENA connection process, there's another link to it there. And finally, I put on there MCOPA, the Meter Operators Code of Practice Agreement, produce a guidance document, which is originally it was intended for meter operators and people working at the service position, but it does give some guidance on some of the things to look out for, typical defects or faults at the service position. That's free to download, and the link is available there. So, coming towards the end, we've been connecting these devices for really a couple of years now, and there are some common things we've observed. It's quite common for when there's an application for a heat pump for the installer to put on the form the thermal output rather than the electrical input to the device. It's quite important because generally the thermal output is going to be of an order of 2 or 3 times greater than the electrical input, and that could make the connection difficult. So it's important to check you've put the electrical input on. Loop services, I mentioned our policy is to remove loops, to unloop. This can involve excavation at the customer's property. So the sooner they're made aware of that, I would say the better. We have found situations where things have been installed and we've had to go back afterwards and excavate driveways and so on. So it would be, from Electricity Northwest's point of view, it would be very helpful if customers could be made aware if you come across a loop service. Rural areas, generally the network is not as strong as urban type areas. So if you are looking to install high capacity devices in these types of areas, it's generally more likely that we may need to reinforce the network to accommodate it. Similarly, locations close to substations are better than at remote ends. So again, if we have developers who are looking to install numbers of devices in an area, it may be worth, before you apply, coming in and talking to us. So we could, give advice on locations of substations if you've got the flexibility to put them in different areas. That brings me to the end of the slides. So we do have a final question session, if anybody's thought of some questions.
We've actually had a few come through on the chat direct to us, so we'll run through those questions first, and then I will unmute everyone to allow you to ask questions on the call.
So the first question we've had is, what information is required when applying? We do require the harmonic emission currents from 2 to 50. That is more, there's 2 sort of aspects to this. If it's the smaller ones and they are compliant with the specifications detailed by the ENA, we may not need these. But if it's a larger EV charger, in order for us to carry out a stage 1 harmonic assessment, we do need the harmonic emission currents from 2 to 50. We also require the total thermal capacity requirements. So what we tend to find is when somebody's applying and they have an existing supply, so it may be a garage forecourt that already has 150 kVA of maximum import capacity. If these charges are to be used outside of the maximum demand, it may mean that they don't need an increase in capacity, but that's something that you would need to sort of specify when applying. The second question has come through, similar to what I've just said actually. If the EV charger is being connected to an existing supply, does the supply require a maximum input capacity increase? So again, this is sort of determined by the customer. Some customers install chargers and charge vehicles throughout the night, the company vehicles that are being charged through the night, where the maximum demand is quite low and it's not impacting on the maximum import capacity. Another question that's come through, will ENW carry out a G5 harmonic assessment? If the customer provides us with all the harmonic emission currents, ENW will carry out a stage 1 assessment. If it's on the a stage 1 assessment is only applicable to LV connections. So if it's a large supply that's on either a HV existing exit point or they require a HV new exit point, we would be in the realms of a stage 2 assessment. But if it's an LV either point of connection or an existing LV supply, ENW will carry out a stage 1 assessment in line with ENA engineering recommendation G5. But to do so, we do need the emission currents. That's really important. We do get a lot of people applying that don't provide us the emission currents from 2 to 50. So we cannot carry out that assessment without that information. And the last question I've got here, will ENW carry out a stage 2 assessment? ENW do not carry out stage 2 assessments on behalf of clients. What ENW do carry out is we will go out and measure the background levels. We record the background levels for a week at the point of common coupling, and we provide that information in order for the client to carry out a stage 2 assessment.
Okay, I will now unmute everyone. So if you do have any questions, please feel free to shout out. Okay, so we have a question. Where you have a larger heat pump system, which is simply controlled by sequential one-off switching of a number of compressors, i.e. no inverters, why would we need harmonic emission currents?
The answer is we probably wouldn't, because there's no likely source of harmonic currents. What we would need to consider is flicker and step if you've got a number of compressors effectively direct online starting. So it's a good question. I think that the focus would be more on the voltage rather than the harmonic currents.
Any more questions?
Okay, well, I think there's no more questions coming through, so thank you very much for joining us today, and I hope it's been useful. And we will be putting the slides up on the website shortly for you to look at, and obviously remember all the links in there are very useful, taking you to various different websites and policy documents. So thanks again for joining, and I hope you found it useful. Thank you.